Awesome. Okay, good morning, everyone. Let's get started. Hopefully everyone here is having a great and awesome time here at Ignite. My name is Kevin, and I'm here on stage with my colleague, JRJ. And we're both program managers on the Azure SQL Data Warehouse engineering team. So if anyone has any questions, feel free to reach out to us or drop us an email. Our emails are conveniently JRJ and Kevin@Microsoft.com. So today we're speaking about SQL Data Warehouse. So can I just get a raise of hands on who has a SQL Data Warehouse instance? All right, awesome. Almost everybody. So really, SQL Data Warehouse, we have just declared general availability in the month of July. So it's a really exciting time for us. And today we'll be speaking about scaling, specifically configuration and going through the guidance of scaling, how to really size your SQL Data Warehouse, specifically going over what factors tune your SQL Data Warehouse for you to meet your expectations of a data warehousing solution running in the cloud. So quickly the agenda. JRJ and I really hope everyone here gets a lot of value out of our session, where we'll be going over the compute scaling factors, along with the storage consumption model, going over how they impact the performance, the behavior of our system, in order to help everyone here develop cost-efficient data warehousing solutions using our service. And then we'll be going over some pricing scenarios to really understand what really drives overall cost using SQL Data Warehouse, and then doing a Q&A at the very end of the session. So quickly, I want to go over quickly some elastic scale concepts, specifically some fundamentals on SQL Data Warehouse. So first, SQL Data Warehouse, in terms of the architecture, we have MPP architecture, or distributed architecture, where you push down your query computation over a set of compute nodes. But really what we want to emphasize for this session here is how the storage layer is separate from the compute layer. Sorry, the clicker is stalling. So to emphasize, we have a separation of compute from storage. So with SQL Data Warehouse, not only is this one of our key value propositions, and it's a differentiator against many other products, but it's also a shift in the traditional way of thinking about how to price and really how to operate a data warehousing system. In traditional way, in the on-premise world, we would be actually pricing POCs and data warehousing system based off a fixed ratio of compute and storage, right? And normally, these systems would be forecasted 3 to 5 years in advance based off of high or peak utilization times. And then ultimately you come into these situations where you've overpaid and over-provisioned for a system that's never fully in use. You have a situation where you have your data warehousing system idle in your data center for hours or days without any usage, right? But with SQL Data Warehouse, we have really changed this way of thinking by decoupling both the compute layer and the storage layer, being able to independently scale compute from storage, where you can essentially scale up whenever you're driving usage with the service, and scale down whenever you're not, whenever you're driving less usage. And we also take it a step further, where we're able to pause and resume your workload, where we could essentially turn off your compute, effectively turning off your entire compute bill, and then resuming it whenever we're expecting to drive any usage. So now when you're thinking about how to price or how you operate a data warehousing system, you can really thinking about, you can be more accurate, more flexible in terms of how you're going to be using the system on a more of an hourly basis, just because we charge for the highest compute during the hour. So you can be more flexible in that aspect, taking advantage of the dynamic scaling of SQL Data Warehouse. Okay, so SQL Data Warehouse, we also have a concept of geo-redundancy. So to enable data protection scenarios, what we're doing is we're taking a full database snapshot or backup of your data that's lying in premium file storage. That's automatically locally redundant. We have 3 replicas in the primary data center. And we're copying that over to standard storage, which is automatically geo-redundant, right? And when we do this, essentially what this does is we do this on a 24-hour basis. So we offer a 24-hour PO. And note that it's not geo-replication, it's geo-redundancy. So we're not guaranteeing 2 data warehousing instances in 2 regions, but rather we guarantee that you have your data available for you in a different data center where you're able to restore your instance within a 24-hour period. So we do this. This happens on a 24-hour basis, and we offer a 24-hour PO, and it's on by default. And for SQL Data Warehouse, we also introduced a concept called DWU, Data Warehousing Unit. So this is really a measure of overall performance of your system, and it's it's more of an abstraction of hardware specifics. So yeah, when you increase your DWU, you are increasing your number of your compute nodes, you're increasing CPU, you're increasing RAM, you're increasing your I/O, but really it also governs many other factors, such as transaction size limits, load rates, TempDB, concurrency, many of the things that JJ will be going over in the next few slides, but really to keep in mind is that it's really a measurement of overall performance. So when you scale your DW up, you can expect that your data warehousing workload will scale linearly as well. And today we support from DW 100 to DW 6000, so you're about 60 seconds away from increasing your performance 60 times faster. And then next, we're going to have Jared J going over what it truly means to actually scale your system and how DWU affects the behavior of your system. Jared J?
Thanks, Kevin. And hello, everybody. So I want to talk about compute scaling and what that really means, because really it's about those core resources of CPU, memory, and I/O, and we do a pretty good job of abstracting some of that complexity away. But when it comes to actually sizing the warehouse and thinking about where you might want to start your settings and all the rest of it, sometimes you need to have a little bit more information to be able to kind of work with it and also make the most appropriate settings at the right times. So let's start with this slide here. This is what we call like a sizing by capacity. Most people have an idea of how much data they have. They don't necessarily know what the workload pattern is, but they've got an idea of what the capacity they have is. And this is sort of like what I would say is this is the starter for 10, right? So if you want to just kind of get some initial kind of gut feel on where the slider should be, right? This is kind of going to start you off in the right direction. Okay, so you can see that there is a range here that we kind of are prescribing depending on where you are. But this is just like a starter for 10, and it really is capacity. And if anyone's worked in the world of building data warehouses, capacity really isn't the be-all and end-all measure. If you've looked at any of the fast-track data warehouse reference architectures, things like that, you'll know that it's a balance of CPU, memory, and I/O that leads to a good, well-tuned, and optimized system. But people don't really understand that CPU memory in terms of their systems or queries or whatever. They have an idea, but they don't really, it's very hard for people to kind of really talk about that. And that's at least in my experience when going into customers and trying to think about systems, especially greenfield, where they haven't actually built anything yet, right? So this is just to kind of give people a rough idea. It gives them a starting point, because the compute is where it has a level of cost to it. But what I want to do is start to dig in a little bit and start thinking about why those scaling factors might make you change your DWU setting, right? Might make you change it up, might make you change it down. And the ones that I want to pick on are concurrency, transaction size, load, and memory within the concept of compute scaling, right? Which is when you're moving the slider, you're moving the amount of compute that's available to you. So we wrap all of this up, and we call this a data warehouse unit. And so let's kind of break it down a little bit and start thinking about the individual workloads. So in SQL DW, we start with the concept of concurrency at the session level. And we support 1,024 open concurrent sessions on the database. But that is like a funnel into a queuing system, right? And the queuing system at its maximum is 32 active queries, okay? Which means that if you have 33 active queries and we have maximum concurrency, then the third query will be queued whilst we wait. Now, the reason we do this is so that we can provide optimum resources to the ones that are running. Because in this sort of a kind of a workload, data warehouse workload, what you want to make sure is that each query that's being fed in has a good balance of memory, CPU, and I/O to be able to get through the workload as quickly as possible. And in many cases, it's actually better to actually run with less concurrency, but more resources per query than it is just to try and throw more and more and more queries at the system, right? So SQL Data Warehouse is optimized in this way for these deeper, bigger queries. I mean, at the end of the day, as Kevin will tell you, is we can store an enormous amount of data in Data Warehouse, SQL Data Warehouse. So it's really about making sure that we can access it in good timescales. Now, I did mention that 32 active queries is kind of like, that's our maximum. Now, there is actually a thing we have in that concurrency model called a concurrency slot. Now, in the concurrency slots, you can see that the actual number of maximum concurrency slots actually scales as you increase the DWU till the point that you keep going up and up and up. And you'll see that that exceeds the 32 concurrent query limit, which we'll get to in a second, right? So the point here is that we actually have two separate concepts. The first is the number of slots in the system. The slots are a reservation of resource, okay? Now, with a slot, your queries are aligned to a resource class. So for those of you who are familiar with the concept of resource governance in SQL Server, these are resource classes that are similar to that. So these resource classes govern the amount of memory that you have access to. So at the base level, you get roughly 100 megabytes of memory per distribution in our distributed system, and it goes up and up and up as we go. Medium, large, extra large, okay? Now, what we have is the base level is that you get one query has one slot, okay? Now, as you increase your resource class consumption, which gives you greater resources, you consume more slots, right? So in DW100, if I want to run a query with a higher amount of resource, he consumes more slots, right? So my concurrency is impacted. Now, roughly, depending on how this goes, you start with the small. The small is always one concurrency slot. But as you go up the resource class, you start increasing the number of slots that you consume, and that impacts the number of queries that you can have. So this slide is showing you that basically when you were running in the extra large resource class, if you have a query running in that extra large resource class, because we give that extra large resource class so many resources, your concurrency is effectively 1, right? So if you are a DBA and you're in a system, the last thing you want is to have a pool of like the DBAs and give themselves the extra large resource class because you've basically just serialized every access point they've got in the whole system. But these extra resource classes are very useful because they align you and they empower you with more memory and resource capabilities under the system, under the hood. Brilliant. So the second thing we have is the concurrent queries. And the concurrent queries is this limit of number of queries that can run on the system. And again, this scales as the system scales. So we start at DW100 with 4 concurrent queries, okay? So if you've got 4 concurrent queries, and each one by default consumes 1 slot, right? You know that you can have a combined effort of 4 queries running in the system, okay? So one of the things when we go back to that initial slide is saying, well, if the first thing you know is the capacity, but you have some idea on your concurrency, then you will know to move the slider more towards the right, and that's why they're banded, to get more concurrency in the system if that's something that you require. The second thing to think about is transaction size. Now, when we think about transactions, we're thinking about things that are going to update and delete data, things like that. And the reason why we think about updates and deletes in particular is because those two patterns are what we call fully logged operations in the database. And fully logged operations are very resource intensive, and they have very large rollback consequences. And because we can hold an enormous amount of data in SQL Data Warehouse, the last thing you want is a very, very long-running accidental update or a delete. Imagine someone just writes update table on some enormo table and forgets the where clause. So we have these bounds in the system to kind of help protect you. Now, that doesn't mean to say that in your world, you might need to do a certain operation that is very intensive. So again, this is helping you to understand that you might need, if you encountered the error, there's an error message that would pop if you exceed the limit, that you might need to move the slider in order to get greater transaction size capability in the system. Now, when it comes to data loading is an incredibly common pattern that people will tend to look at when it comes to writing and loading data into SQL Data Warehouse. Okay? Now, the reason why they look at loading is because loading scales linearly as we increase the DWU to about, I think we measured at something internally around 6.5 terabytes an hour at the highest level. Okay? Now, when you're scaling, you actually increase the number of readers that are able to load data. And with this, we're really specifically talking about our Polybase technology, because this is our distributed scale capability. But as you increase the DWU, you're basically increasing your ability to read data faster. Now, as you increase this memory amount, your writers is also increased to make sure that we can also keep pace at the higher levels of DWU. Now, the last thing here is around the takeaway here is around the resource class. And I'll show you a little bit about that when we look at memory in a second. But the resource classes give you access to greater memory. And by default, it's important to remember that SQL Data Warehouse is using column stores, which is very memory hungry system. And when you're loading them, they do like their share of memory. Okay? So actually running with a dedicated user at the higher levels of resource class is really important for in making sure that you are loading the column stores efficiently and maximizing that benefit. Now, in terms of load scaling, this is logarithmic, so that's why it looks like a curve. But I wanted to kind of give you an idea of roughly what your speeds you would expect to see are at what node level. And the nodes, you can think of nodes as sort of DW divided by 100, right? So you can think of it, so you can see that as we are increasing our scaling capability, you should expect to be able to hit some of these kind of numbers with your data loads, right? And specifically, this is with Polybase, because Polybase has this ability to load data really fast, really efficiently. So I certainly encourage customers to be using Polybase where they can in their loads, because as they increase the DWU, they will naturally see the benefits of doing so. Now, there are some gotchas when loading data, which may mean that you don't necessarily see the performance that you were initially expecting. One of those is if your data is in compressed text, okay? Because if you think about a compressed file, or text file, that text file we cannot read, we cannot send multiple readers in parallel to read it. So what will happen is that the compressed text file will be read by a single reader for that text file. So if your data is in compressed text, and we go back and we look at the number of readers on the load screen here, what you would do as a take-home is make sure that I'd split the data I wanted to load into the table into at least this number of files. Because by splitting it, I will make sure, if you tell me I've got these 10 files, right, I will send down 10 readers to read those 10 files, okay? So if you're dealing with compressed text, and when I say compressed text, I mean gzip, not winzip, right? Gzip compression, then you will get the best performance because we can still read the files in parallel, even though we can't read inside the files in parallel. Now, one of the things that you could do if you had it just in a single file and it was compressed, if you had the data in ORC or Parquet file formats, because of the nature of that in that file format, we can read those in parallel, even if they are compressed. Now, memory is incredibly important, as I was saying, about the way we manage memory distribution. SQL DW is column store based, and it does love memory, right? To make sure that when we're compressing the data and encoding the data, we do the best job possible. Now, if you look here, this is how the memory scales as we are increasing our resource classes and also our DWU counts. So you can see that as you go up, I've only done it to DW2000 because it just, you just lose total visibility otherwise, right? And I frankly ran out of colors. So you can see here that as you come up, you can see that there is a stepping up in the memory as you increase both resource class, but also as you increase DWU, right? All of this is documented online, by the way, so I'll show you the specific document in ACOM in a second. But you can see that the memory per distribution is largely increasing as a curve, right, or as in these bars, with the notable exception of the default resource class. Now, the default resource class, when you just create a login and create a user, they are by definition in the default resource class, or the small rc. And you can see that that does not increase its memory allocation. Now, generally speaking, if someone is just writing simple selects against a database, happy days, not a problem. However, if they are trying to do things like index rebuilds or anything material on that database, right, then they're not going to get the memory that they want or need. Okay? Now, there is a slight also thing to take into consideration. You see I've put this big flag here, right? I've done that for a reason. It wasn't just for giggles. That is the service admin account. When you create a SQL data warehouse and you go through the GUI, as all of you must have done at some point, because so many of you have SQL data warehouses, you will have created a login, right, when you first did it. Yeah, you created the service admin account, and yeah, you gave it a username and a password. That is the equivalent of the SA account in SQL Server, okay? Now, the difference is the service admin account, he sits in here, but he cannot come out of it, right? We do not today let the service admin account be added into higher resource classes, okay? So the take home here is that if you are doing ETL, please create a different user and just adhere to the spirit of sort of 15 years of guidance about not using the SA account for general day-to-day operations. Create a dedicated account for your ETL utilization and run in that account so that you can leverage the goodness of the higher resource classes for memory. Okay, has everyone got that? Right? It's very important, right? Yeah, for sure. Okay, So one of the things when you're running queries is that you have this thing called a memory grant. Every query gets its memory grant, okay? And this memory grant has a number of sizing factors that take into account, okay? And these are the sizing factors. And it's the number of rows in the row group, the overhead, the number of columns, the short string character type columns, i.e. anything it's either less than and equal to less than 32 bytes, right? And a long string is here, this long string type columns. Anything greater than that is considered to be a long string. And the algorithm, when it's working out how much memory you need to perform the operation, like an index rebuild, takes into account all of these factors, okay? Now, I'm going to show you some examples of how this might impact you. So here, on the left, we're targeting 250,000 rows in a row group. And here, we're targeting 750,000 rows in a row group. Now, why did I pick these two numbers? So the first reason I picked these two numbers is because the maximum number of rows in a row group, as I'm sure many of you know, is 1,048,576 rows in the row group, and that is per partition per distribution. Okay? It's a very long sentence. So now, therefore, anything above 102,400 rows per partition per distribution, when you write that in as a chunk, that will write straight to the column store. Okay? If it's less than that, it goes into the delta store. But here, this is a basic algorithm. Now, in order to get to 250,000 rows in a row group, if we think about our table and we think about the characteristics of the types that we just discussed, we have here a 10-column table. And this is all of the columns, right? So if this is 10 columns with no short strings and no long strings, we need under 100 megabytes per distribution, i.e. the default resource class, absolutely fine. However, if we have a table, and let's say we've got a fact table, and 5 of the columns are now short strings, we actually need more than 100, which means that we're in this space here, okay? Which means that we need between up to 150 megabytes per distribution. What does that mean? It means that we're not going to hit 250,000 rows in the row group, because we'll hit a memory pressure without that, right? So we would need to increase our memory in our resource class to get to that data set. Now, imagine we have a mix, 5 and 5, right? We've got no integers, no date times, okay? Now, we need more than 200 megabytes of memory, okay? And if they're all long strings, I need over 250 megabytes of memory, okay? Now, this is quite a narrow table, 10 columns. Let's see what it's like if we go and we want to target, say, 750,000 rows, okay? So you can now see the memory sizes are going upwards of 300 plus megabytes of memory to get to 750,000. Now, the reason I'm calling this out is because this is a small table. Imagine what it's like when it gets to big, wide tables, right? Some people, I've seen customers creating very wide tables and trying to use column stores with them and being surprised when they have memory pressures and challenges, which means they're not getting to the right levels of compression. So here is some guidance, and I've got some demo code, which I share with everybody. It's not a problem, that you can use to help preemptively size these things for yourselves as well. Okay? Now, let's have a look once this thing finally moves over, right? This is a 30-column table. So to kind of really bring it home, right, just look at this one. This is 30 columns, right, and with all 30 in the short string. The overhead of the short strings over the base columns, base column overhead, right, takes you up to needing almost a gig of memory per distribution, right? So how can you optimize for this? First thing is don't be lazy with the types, right? Does the data need to be a string, right? Because if it's integer, big int, or date times, or date-based types, those things do not have this same overhead, right, where you have a different way of dealing with them. So fact tables where you're doing this type of stuff is much more preferable if they are numeric-based types or date types. Okay? Now, I'm going to switch over. Is it 7? And I'm going to try and show you a little bit of this kind of in action. So what we're doing here, hopefully, let's just see if I can create it even bigger. I've got some tables that I created. Let's give it a that. OK, and I've created a user. And just so you can see at the top, I've created a user for a login, and I've given him a level of control on the database. So he's like an SA user. And then I've added him to the extra large resource, to the medium resource class in this case. Now, to generate my data, I'm using an adaptation of something from Itzik Ben-Gan, which was this function he created called fnnums, to generate 60 million rows. And then I'm loading that data into various tables, right? So that 1000, and you can see that I'm using well, you can't see yet because it's just not quite on the page. I'm using the result of that temporary table to populate this with various data, right? And you can see here's one that I've created with just integers. Here's one with mixed, with five variables. Very vast strings. Here's a short string and wider string range, and then here's just long strings, right? So this is some basic tables that we've created for the purposes of the demo. And then the other thing I have created are some views, and the views are things that I try and publish on the Azure.com documentation site. They're quite long, but once you create them, the point of it is that you can just use them yourselves, right? So the point of this one is to monitor the row groups. So it'll tell you how many rows are in the row groups. And we're using some of these key DMVs here around nodes, column store, row groups to be able to manage it. So if you're used to SQL Server, you will see that we have this PDW nodes prefixing the column store row groups DMV. The basic data is the same. We have some additional columns, and the PDW nodes is telling you that we're hitting the scale-out distributed tables. Okay? This is the first one. This is the row groups table. So this tells us how many rows are in the row group. This is the memory grant view. And in this view, what I'm trying to do here is to show you how much memory you require to hit 1 million rows in the row group. So I've just kind of shrunk it a little bit here. But what it's trying to do is it first of all identifies all the tables and columns that are less than or longer than 32 bytes. And then it summarizes that data and then performs a calculation to tell you how much that memory grant actually is. And then the last one we're going to look at is dictionaries, and I'll talk about that when we get there, right? Now, the first thing I want to do is to connect over here and come up to the top and show you this table here. So this is using that mon row group. So the first thing to do is to analyze a table, and I've picked one of our tables, which is the widest one, right? The 10 10 columns, all of them wide varchars. And when I run this table, this query, I can see all of the distributions. And at the top, I can see that the average number of row groups in the row is 500,000. Okay? And I can see that each distribution of the scale-out system has got 2 row groups, right? Which means that the rows have been split between 2 row groups. Some memory pressure must have kicked in because we have the 10 string ones. And remember what I said is that if you're over that 10 amount, then we're going to need more memory, okay? So then I'm going to go and say, okay, I'm going to come over here and look at the memory grant view I looked at to see how much memory to do do I need to be able to do, say, for example, an in-memory rebuild of the table. Okay, so I use that view I shared with you, and I've cut all the columns down just to make it really kind of simple. And you can see that at the bottom here, it says 312 megabytes. Okay, 312 meg is what I actually require. So that default resource class, no worky, right? I need to go up, right? So what I need to do is to go over and have a look at the documentation for a second. And this is the article you want to look at. In the Doc Center for SQL Data Warehouse, we have a number of really good articles. Sonia's taken this one over. And this is the Concurrency and Workload Management in SQL Data Warehouse document. It shows all of that early stuff I had there for you. And then I can come into here and see that I'm running at DW400. How do I get over 300, right? Well, I'm going to use the 400 megabytes I get with the medium RC, okay? So I can now assign myself into that medium RC using SP add role member, right? And I will be able to get I will be able to exceed that figure. So rather than watch an index rebuild, which is honestly more boring than watching paint dry, I actually have done that for you earlier. So you can now see a rebuild that has happened on that table. And you can see that the number of row groups is now singular per distribution. There's the distribution IDs. But all of the rows are now in the row group that's tied to the maximum. So we've been able to actually reduce the number of row groups in the column store, optimizing the column store by compressing the data more effectively by knowing how to give it more memory. Okay, so we've got that in our locker. Okay. Now, that's all well and good, but sometimes you hit this thing called memory pressure from dictionaries. When we have variable length strings, we are actually substituting in a column store, and we create these things called dictionaries that hold the actual string values. And these things have, these dictionaries have capacity limits in them that mean that we sometimes release a row group earlier than we might expect, right? Because the dictionary can only hold 16 megabytes of memory in memory per dictionary, okay? So what can happen is that if you have a certain type of table that is very, that's maybe got a large number of strings, but they're all very distinct, you can actually fill these dictionaries very fast, okay? And when these dictionaries get filled very quickly, they will have to release the row group prematurely. So I've got the same volume of data, but on this table, I have this varchar 1000 column. And how I populated it, just so you can see, is that I created this table here, but I've created it with this replicate B950 concatenated to the unique number of the table, right? So I've created unique rows that are very wide in nature, and I've thrust those into the dictionary, okay? So the dictionary didn't thank me very much, as you will see in a second. Okay? So now, if I actually go and look at this table, which is the same table, but with this extra wide column, you will see that the number of this row group is 19 per distribution, right? So rather than it being 1 or 2, I now have 19 row groups, which means I'm not getting the compression on the data that I would optimally like to see. And the average number of rows is actually 50,000 rows in the row group. Okay? Now, if you see something like this, you might be more suspicious of dictionary pressure. Okay? So when you have dictionary pressure, the way to look at it is to come into this other view I created for you, this V dictionary pressures view, which is this one over here, which looks into PDW nodes column store dictionaries and starts teasing out some of this data for you. So I've just created it for you as a simple select, so we can just run this. And you can see I've ordered it by the number of dictionaries. And can you see that the number has skewed massively? So you can see all of the other columns in the database, right? I got 60 dictionaries because I have 60 distributions. So that's what I would expect. And I've divided that by the number of distributions, so I can see that I have 1. But you can see this one guy here, the number 10, the 10th column, which is our wide column with unique values. Okay, I've got 1,200 dictionaries. So I know I have, from this data, a trimming happening from dictionary counts. So what I can do with this data is start thinking about how to redesign the table and start looking at this column and saying, do I really want this column in a column store? Right? Because this is not something that's going to, you can't just magic this away, right? You have to think about whether I want to separate this column out, maybe hold it in some kind of junk dimension, and link into that table, and so that the column store can take advantage of it. So if I was to eliminate that column from this table and replace it with a surrogate, like an integer-based join, I'd be able to join into it when I needed it, right? And maybe go at it like that. Yeah? They do, yeah. For sure. And I'm showing you, especially because SQL Data Warehouse is distributed system, we're actually looking at it across, say, 60 SQL DBs. So I'm showing you how to make that make sense across the 60. But all of this basic stuff is just as applicable in SQL 16 as well. So that's what I wanted to show you, and now I'm going to hand back to Kevin, who's going to talk about storage sizing.
Okay, thank you, Jared J. So let's go back to the 5th one. So next we'll be speaking about storage sizing, specifically diving into the storage consumption model and really how it impacts billing in terms of the data you're storing in each of these tiers. So what we've done for storage is we divided storage into 3 separate tiers. First, we have the local storage tier, and mainly the tier is just for us to understand what data is being built in each tier and how it's being impacted by when you scale your DWU, when you move your slider from left to right. So in terms of the storage tiers, we have the local storage tier, we have the premium storage tier, which is the remote storage tier, and again, any instances lying in GA regions today is running on premium storage. And then we have the blob storage tier, which is your geo-redundant storage. Yeah, so in terms of the actual data that lies in each tier, we have your tempDB lying in the local storage tier. We have your data files and log files, so your MDF and LDF files and your snapshots in the premium storage tier. And then you have your geo backups within the blob tier. Also note that everything in the premium tier and the blob tier is what we are charging you for in terms of storage. And so to actually go into the data within each of these tiers, we have your tempdb, which stores your queue tables for your DSQL operations. It stores your temp tables. But main thing to note on this slide is really tempdb scales as you increase your DWU. And this is really the only tier that is being impacted by what DWU you're at. And you could expect a linear scaling when you increase DWU of your tempdb size, specifically around 400 gigabytes per DWU 100 node. And also note that we scale all the way up to DWU 6,000 for every instance that's lying on premium storage. And in terms of the premium storage, tier, this is really mainly where the bulk of your data lies and really where you're going to be charged for. So we're going to be speaking about in terms of the capacity. So if running on premium storage, we now support 4 data files per distribution. And each data file has a maximum capacity of 1 terabyte each. So with SQL Data Warehouse, we have 60 distributions. So we divide up your entire data into 60 distributions. So we support up to 240 terabytes of file capacity. Assuming you have CCI for your tables, we normally see about 5 to 10x compression rates. So we can actually effectively store up to 1 petabyte's worth of raw user data on disk. Okay, and the actual data within premium storage is actually the database size. And this is mainly just the reserve space, the log space, and the unallocated portion. To go into mainly the unallocated portion, the unused portion, the unallocated portion of your database size is essentially the space available for your database that has not been reserved for any database objects. For your unused portion, this is essentially reserved space but has not been essentially used by any database objects. And then it's straightforward for the index data and logs, which is space for your index files, your data, and your log files. But mainly for this, the takeaway is that you are billed for everything in your premium storage tier. So you're billed for your entire database size. And to go more into depth with this means that you are billed for your unallocated space within your database size, within your database. So say we're going to go through a quick scenario here. So say you load your data. You have 16 terabytes worth of data within your data warehouse. You run some analytical queries, and you realize that your database is not as performant as you expect it to be. You realize that you don't have CCI on your tables, so you drop your tables, and you reload from Azure Blob Storage via Polybase in CCI tables, where now you have 4 terabytes of reserve space and 12 terabytes of unallocated space. The main thing is that note that these two scenarios are both equivalent from the billing perspective. So you're still being charged for your unallocated space. So really, you're being charged for the high watermark of your database at the high maximum database size it was ever at. So there's something just to keep in mind of, just in case you're doing these large deletes or truncations or updates. If you run into this scenario, you can call support where we'll shrink your database files on your behalf. But again, something to keep in mind if you're not doing any near-term loading after you're doing these major truncations or deletions from your database.
Yeah, and it's really just as a kind of a scenario that we have encountered it with one customer. We just want to make sure that people are aware of the scenario. So it's really about, so if you've done a whole bunch of work and then you maybe drop loads of tables and stuff like that, then obviously the files don't we're not insane, right? We haven't enabled auto shrink or anything like that. We bring that down and we want to just manage it right now, right? At some point in the future, obviously, we'll look to improve the experience, but we want to make sure that you understand that just dropping the tables doesn't affect the storage that you have consumed, right? Mm-hmm. So that's the key message here.
Okay, so in the premium storage tier, we also have our snapshots. So snapshots, you can programmatically see in DMVs. We take the frequency of snapshots every 4 hours, and we offer a RPO, so we guarantee of 8 hours. We retain every snapshot for 7 days, and note that snapshots are differential, so you're only being charged for the pages that have been changed since your last snapshot. And in the blob storage tier, sorry, let's go back. In the blob storage tier, we also have our geo-redundant backups that we spoke about in the very beginning of the session. We have one geo-redundant backup every 24 hours. This feature is on by default, where you can go in the portal to disable it should you not need a DR solution for your data warehouse. So again, this is not geo-replication, it's geo-redundancy, where we assure you that you're able to restore your instance in any other region should anything happen to your primary data center, your primary data.
Yeah, and this backup's actually held in the, remember it's held in the Azure Blob Storage, so the charging is based on the GRS rates, RAGRS. Yep.
And then next, we have capping storage capacity. So customers today, we can actually cap our database size or our storage capacity using max size when you create your database or whenever you want to configure it using Alter Database. Mainly max size is a user-defined upper bound of what your database can grow to. So it's user-defined, and it's really just is a way to act as a guardrail to prevent storage from growing beyond your expectations, and allows you to essentially prevent runaway growth, allowing you to manage your storage cost using this user-defined value. Note that it doesn't affect billing in any way, besides throwing an error if your database size do surpass the max size value. Also note that when you create your data warehouse within the portal, max size is 10 terabytes by default. So there's a misconception sometimes that some people believe that SQL Data Warehouse only supports up to 10 terabytes of file capacity. Again, this is not true. We support up to 240 terabytes. So if you do create your data warehouse within the portal, you can go through T-SQL and modify the max size to being 240 terabytes should you need that much space. Also note this does take into account CCI compression. So this is on disk, comparing that value to max size.
And it really is just, this is kind of like just like a safety net, right? Mm-hmm. So it's basically, you think about someone doing some kind of, crazy join, create table as select, where they do this runaway query, and it's just to avoid that creating the artificial high watermark, right? Mm-hmm. I'll do it.
Yeah, OK. And next, we have a summary quick of the storage sizing. So to programmatically view how much data is lying in each of these tiers that we just talked about, you can run SP space use, which is a stored procedure to figure out the database size, which just breaks it down to the unallocated portion, the reserved space, and the logs. So you can figure out, run SP space use to figure out the database size and the free space, or the unallocated portion. Table sizing, we have DMVs that we've created, and also views that we've created to figure out how much data each of your tables are consuming. And this is on our ACOM docs for reference in case you're curious about how much data is in each of these tables, each of your tables. And then again, to figure out your snapshot size, you can run SP space use to figure out the database size and subtracting that from the total storage size that's visible in the portal. Note that we are working on having all this visible within the portal and 3M DMVs, but this is right here is just a summary of how to programmatically view or understand how much data is in each of your tiers. And then next, we're going to have JJ go over real quick the costing analysis and some pricing scenarios of SQL Data Warehouse.
Thanks, Kevin.
Yep.
So so just trying to bring this together, we've kind of talked about some of the sizing and compute from scaling of compute and our sizing of storage. But it's now worth talking about pricing because it's really about what things do you need to focus on and why, right? From your perspective. The great advantage that we have is this operational capability to change the application pattern so that we scale up for the periods of demand. And actually, in some cases, it's actually preferable to scale up to do something quicker because it actually costs you less than trying to drag it out over a period of time, right? So you can work within these parameters. So the thing to start with is that it's roughly going to cost you about $900 per DW100 per month if this thing was on lights on 24/7 or 744 billable hours, which is the sort of the traditional Azure unit of measure. As opposed to the storage sizing, which is $122.88 per terabyte per month, which incorporates, as we've already discussed, the data files, the log files, your snapshots in that premium storage tier. Okay? So if you think about it like that, if we're running at DWU 100, right, what are we actually saying? We're saying that it is literally like 9 to 1, right, in terms of cost ratio. So why do we spend so much time talking about compute scaling and when you need and how much do you need? Is because that's the thing that's going to kind of drive a large part of your of your consumption bill, right? And they come through as different line items on the bill as well. Because they are decoupled, they come through as separate charges, right? So you'll get, the first thing would be your compute, then your storage, and then you'd get the pricing for the, if you have the geo-redundant backups enabled, then you'll get the geo-redundant backup price, which is approximately 12 cents per gigabyte per month, right? Now, some of these prices have slight regional variances, but this gives you the right kind of ballparks to be thinking about. Okay? Clickers, give me some. So I wanted to kind of bring this into kind of some thoughts for you, because there is ways of thinking about this. So for example, if we had less than a terabyte at DW100, and we have, we charge in terabyte increments, okay? And on top of that, we have this DW100 cost. So you can see roughly what the sizes are, and you can see how they impact one another in terms of size. And as we go up, you can see that DW500, if I had 10 terabytes of that, this is what it would look like, and so on, 15,000, 3,000, and 100 terabytes, right? On top of this, that's the base storage cost. The other way of thinking about it is to flip them and talk about it in like terms of an 80-20 rule or a 70-30 rule, as you can see. But the basic rule here is to really focus in on how you're using your compute rather than necessarily how you use your storage, right? So in many cases, it's a lot easier, even though we talk about the high watermark and things like that on the storage, keep in mind that actually the thing that drives your consumption really tends to be around the compute, and the way to keep your for your efficient use of the warehouse is to leverage the pause capability and the scale capability to optimize with your workload. The idea is that those capabilities are your friends, right? They're there to give you improvements in your perf, but also to optimize your experience. So I want to kind of just kind of summarize up everything that hopefully you will have seen today and be able to kind of take out of the session, because we've covered a lot of things, right? And I want to give you an opportunity to ask some questions as well. So the mics are there if anyone has any specific questions about anything that we've talked about today or anything else that has maybe popped up in the week whilst you've been igniting your experience with SQL Data Warehouse. Let's think about what we've actually seen so far today and got some takeaways from that. So the first thing is that hopefully you've seen is some of the key elastic scale concepts, right? So what's that? The first thing that we've seen is that ability, the separation of the compute and the storage, but the scale of the concept was that you can pause the warehouse and you can size it at any time, right? So one of the concept, when I speak to our colleagues in the field and our customers, is one of the things I say is you're 60 seconds away from revising your sizing estimate, right? Whereas if you think about when customers typically have to size a warehouse today, they literally say, well, on Monday morning, I have to get these reports out. And in order to get these reports out for Monday morning, I need 80 cores of SQL. I need this much storage. I need this many servers, and then I need to make it all highly available and all those sorts of things, right? So they do all of that, size it all up, and they have to then license for that peak, right? They then load all the data in a cube, right? And then the warehouse just sits there and does nothing all day, right? Or they have some advanced power users that are allowed on the warehouse. Everybody else goes through the dashboard or whatever, right? They go into a data mart, whatever it might be. But the warehouse is not there. But that warehouse, right? That warehouse is still consuming all the cores, right? In terms of from a licensing perspective. So it's sized to the peaks, right? Now the other thing is that I've seen this a number of times. People say, I've got these aspirations for this warehouse. We're going to be sticking this much data in. It's going to grow 40% year on year. And I have a hardware lifecycle retention policy of 4 years, 5 years. So you need to make sure that I have sufficient capacity for the 5 years. OK? Well, many things change in 5 years. OK? And so whilst they may have made a good estimate, it may be that things change, and maybe they are undersized, which is not so common. What tends to be is people get very pessimistic, and they oversize, they over-provision, they have a very large consumption, and they wait to the end of the hardware lifecycle, and as they're building up, it's actually towards the end of the hardware lifecycle that they're actually even getting close to where they thought they were going to be. What we have introduced with this elastic scale concept is this ability for you to separate from that and run it at an operational model and saying, well, what do I need to satisfy my requirements today and the workload that I am doing now? I think of it as more as like a just-in-time sizing model. And it's a thing to have to try and understand and try and get your head around, because it is a difference in terms of moving from a CapEx model to an OpEx model. But it is incredibly important for understanding the value prop of what SQL Data Warehouse can bring to you and to an organization, especially if you have application patterns where the warehouse has a peak and then very light usage from that period on because the data has been pushed into a cube or whatever it might be. Now, hopefully you have got also some good insights around scaling for the compute, because the compute is what drives the cost, okay? And when you're thinking about the compute as a cost, thinking about how you actually maximize that, what benefits you require, right? What needs you have, right? Do I need this amount of capacity? Do I have this? What are my concurrency requirements? You know, do I have some very heavy update statements that need to be written, right? In which case, you might need to increase the slider in order to be able to more effectively use the warehouse, okay? So it's not just a question of saying, I've got, 10 terabytes, look on there, okay, I'll pick somewhere in the middle and away I go. That's a good starting point, but you will learn and you will realize that there are times when you could deal with more and there are times when you could use less. And so using this compute scaling factors to your advantage is a good way of maintaining that operational efficiency in how you're working with SQL Data Warehouse. The second thing is we want to be very transparent with you about the storage model so that you understand basically what you're being charged for, but also how you can use the system to your advantage. We are taking snapshots at a very regular basis, like every 4 hours or so you can use those to do restores of the database back to those points in time within a 7-day period, or you can use the geo-redundancy and leverage more cloud-based architectures. I don't know how many of you have ever actually tried to implement your at-home DR plans. I can tell you, I have yet to see a customer execute flawlessly their DR plan and everything magically pop up on the other side, right? It's very, very rare, but the cloud does kind of commoditize some aspects of that for you, and you should really think about how you can leverage that in your environments. Similarly, if you're in that dev and test world, you might not need geo-redundancy of the dev data warehouse, in which case you can save yourself some money and switch that off, right? So understanding what we have shown you today in terms of the configuration, you can disable that, okay? And therefore save some money. Now, lastly, we talked about compute and storage and how they affect the pricing of SQL Data Warehouse. And to my mind, is kind of like, where do you focus your time, right? The storage is the storage, right? The data is in there. Actually, in many cases, it's actually more efficient and better for you to actually think about, if you have large running update statements, and maybe thinking about how you could better rewrite that code so that you don't need to use an update statement. Maybe you use more storage, but maybe you're more efficient in compute, right? And many cases, actually rewriting an update or a delete, and you can ask yourself a question why you might be deleting data out of a data warehouse, the whole point being that you're capturing data over time, not trying to kind of rewrite history. But in the concept of a data warehouse, rather than doing updates on data, especially against column stores, oftentimes it's better to actually create a new object or rebuild a partition, things like that. So you can actually get into those sorts of things and understanding that actually a more efficient compute model actually has benefits in terms of the total line item cost on the bill. So here are our takeaways for the session, okay? Understand how compute scaling and understand how to analyze the column stores for memory requirements so that you are making best use of the column store. I hope to be able to kind of spend more time in other sessions at future events talking about managing of column stores, because I think it's something that does change a little bit about how you might write the patterns compared to traditional row storage databases. But I think it's a good thing for you to understand that we will make those views available so that you haven't anything to worry about. I'm trying to make sure it's all incorporated into the decks as well, so you should have everything. And if not, if you have some burning need, feel free to email myself, jrj@microsoft.com, or kevin@microsoft.com, and we will just send them to you so that you are not impeded in any way, okay? So that you can understand the compute scaling and memory requirements for that configuration to make sure you're making the best use of it. And really taking away that concept that compute scaling is both the primary cost driver, but also it's the performance driver, right? We're not flipping the storage around. That storage, your data sits in premium storage, okay? So that model is largely static, okay? Now, you can get into these different utilization patterns, and thinking about how you can do that is incredibly valuable. So I would do that. And lastly, just to touch on the point that Kevin was making, why we focus on that reserve space is actually reserve space is something that is one of those like SQL Server myths. People miss and think about reserve space. They don't actually understand what it means. And it does pop up in some of our DBCC commands and things like that. So understanding that the storage is not just data in the database, but actually our storage model incorporates the file size is important, and the fact that it's terabyte level granularity, right, in terms of pricing cost. So that, I think, is bringing us to the end of our session. I would really appreciate it if you could give us constructive feedback to our session so that we can improve on the content constantly. It's very important to us that we do that, and I welcome all of your feedback. So please I do encourage you to do that, for not just for us, but also for any of the sessions that you've been to, but especially us. I look forward to hearing from you, and so does Kevin, about your SQL DW adventures. And thank you very much. Enjoy the rest of the day. Enjoy the rest of Ignite. And if we have any questions, now would be a perfect time for you to ask them.
So I have two questions. First, when you showed the geo-redundancy backup slide, that was in a gigabyte scale.
Yes.
And I thought it was like 12 cents per gigabyte. And is that like that's a charge every month. I mean, if we look at terabyte levels and swap that, I mean, aren't we looking like $120 a terabyte for geo-redundancy storage?
The geo-redundant backup, we hold one of those per day over a 24-hour period. So you're paying for one of the backups at one time, right? So if you've got, the simple way to think about it is if you have I'd say a 10 terabyte warehouse, you'll pay for roughly about 10 terabytes of storage in Xstore. The reason why we show it in the gigabyte pricing is because that's how it translates on the bill from the blob storage team.
I mean, but it looked like, I guess, and maybe I'm wrong, but it looked like from the $120 a terabyte or so on the premium storage that the backup storage would be about the same cost.
It's about. I think it comes out about. I can't remember. It's yes. You'd multiply it out, but I thought it was a bit less than that. It's not the same cost.
Less, I think.
Yeah, it is less.
It's under different SKUs. It's under the local. It's under the standard storage, not under premium storage. So it's 12 cents per gigabyte, and I don't think it's on. It's not by the terabyte granularity as well.
Yeah, but if you multiply, it's saying if you multiplied it out.
You multiplied it out.
Yeah.
It looks like per month you're getting charged the same amount.
It's about 100. It's about 110 or something. Yeah.
Okay.
So I think
the other question I had is how in the world did you get Kevin at Microsoft.com?
I don't know. Not even Kevin Turner has it. I'm not sure. I think they just did some random generator or something.
I had to ask for mine. Kevin actually just walked up one day and said, "Congratulations, you're."
Doesn't look like you're one of the first,
Yeah.
people at Microsoft.
I don't know.
Yeah. All right. Anyone? Any other questions? If not, please enjoy the rest of your day.
Thank you.